All right, guys. Hope you're all doing well. We got a really quick video for you all today. Just really 2 slides worth of information I want you to know. There are a couple of extra slides that are in your Chapter 15 notes that I do not need you guys to complete. So we're really just going to focus on these next two here, and that'll kind of be it for the end of Chapter 15 here, okay? So obviously we spent a lot of time talking about equilibrium. Just finished up Le Chatelier's principle, right? And a lot of equilibrium stuff here. And we've talked a lot about what happens at equilibrium or during equilibrium, or what happens to something when equilibrium is shifted, right? But we've not yet really talked too much about, or if at all, about what's happening, when things are not affecting equilibrium, right? So we talked a lot about those three stressors, right? Changing concentration, changing the amount of your reactants or products, changing the volume or pressure of the gas, and then ultimately changing the temperature, right? Those three things can and do affect equilibrium, but there are a handful of things that do not affect equilibrium if they aren't in fact changed in that system, right? So for example, catalysts, right? We spent some time talking about catalysts. What catalysts do is they only really affect the rate of the reaction, okay? So ultimately, right, if you add a catalyst to a particular reaction that is able to essentially have a catalyst, right, all it's going to do is just speed up the reaction, right? It makes it faster, okay? Catalysts, all they do is they speed up both the forward and the reverse reaction, right? The rate of the forward reaction and the rate of the reverse reaction, right? So if you're speeding up the forward reaction, well, in equilibrium, it's going to also speed up the reverse reaction, right? So you basically have this effect where, yeah, you're making, you're having your reactants make product faster, and you're having your product make reactant faster, but it's not really changing anything about the equilibrium, right? The equilibrium is still in equilibrium. Next up here, adding a gas not involved in the reaction into the reaction vessel to increase the pressure, right? So if you're not increasing the pressure sort of by increasing the pressure on the gases that are in fact reacting, right? If you have like some third or fourth extra gas that you're artificially sort of pumping up the pressure, that doesn't actually have any effect on the rate of reaction, okay? Or excuse me, any effect on the equilibrium. Only changes pressure due to changes in volume or changes in the pressure, partial pressure of one of the reactants or one of the products affects the equilibrium, right? So it's very, very specific in terms of what I mean when you increase pressure or decrease volume, right? Next up here, something known as phase equilibrium. And again, this is going to be the very, very last thing that we talk about in Chapter 15 here, okay? Phase equilibrium. So it kind of sounds exactly like it is, right? We've talked about phases being states of matter, right? Solid, liquid, gas, etc., right? But when it comes to phases being in equilibrium, it's basically heavily relating to different phase changes, right? So a phase change, like let's say, melting, right? A phase change of melting, and that would be specifically melting would be solid to liquid, okay? When this melting of, well, of course, water, right? We'll use water as our basic example here. As this melting of water occurs, water is slowly moving from the solid phase to the liquid phase, melting, right? And when it's doing that, there's this sort of equilibrium of the two different phases involved in this phase change that sort of occurs, right? The solid particles of this H2O and the liquid particles of the H2O are sort of in this equilibrium where they're constantly, as temperature starts to slowly increase, right? There's this constant swapping, this constant equilibrium, this constant phase change of solid to liquid, liquid to solid, solid to liquid, liquid to solid, right? It's constantly kind of going back and forth as these particles are slowly melting over a period of time. So it's a sort of an equilibrium that exists between phases at a given temperature, right? And of course, right, let's say, for example, you have a bunch of ice in a cup of water, for example, right? Ice in a cup of water, right? And you have that ice and cup of water exactly measured at 0 degrees Celsius, right? Well, at 0 degrees Celsius, that's the exact same temperature that melting occurs from solid to liquid, but it's technically also the exact same temperature where freezing occurs, right? Liquid to solid, that phase change, right? So you kind of have this back and forth of your two different phase changes all occurring at that same exact temperature, solid to liquid in melting, and liquid to solid in freezing, okay? So it's this phase equilibrium, right? Showing that, equilibriums exist between different states of matter at a very specific temperature, right? So again, a water-ice mixture at 0 degrees Celsius has an equilibrium between the solid and liquid H2O. All right, how to make a quick alteration here to the slide. Here is the sort of written example, right? We always obviously like to look at different chemical equations here. In this chemical equation here, very clearly showcases that we've got H2O as a solid in phase, right? In a phase or in equilibrium with H2O as a liquid, right? And obviously there is no chemical change occurring here, right? And of course we know that there is no chemical change occurring here because the formulas of our two substances have not changed, right? We still have H2O on the left here, and we still have H2O on the right here. So the unchanging, right? The lack of change of actual formulas here, right, of course tells us that we're dealing with only a physical change here, right? And of course, we can clearly see that when we have the S here and the L here, right, representing solid and liquid, okay? So you have this equilibrium between these solid and liquid particles of water at 0 degrees Celsius, right, where they're constantly shifting back and forth, phasing from solid to liquid and then liquid back to solid and whatnot, right? Please, 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 I have this on the slide here. Please mark this slide as important, right? Phase equilibrium is a pretty important concept to sort of end chapter 15 on, and I definitely need you to understand what phase equilibrium is. So please, in some way, shape, or form, mark this slide as important as we close off chapter 15 here, guys. All right, thank you very much, and I will see you in class.